Okay, so I'll solve to sum. I'll do it the brute force way, and then I'll teach the optimal solution. Technically, there's like a million ways you can solve this, but too lazy. So let's see what this problem is asking. Given an array of integers num and an integer target, return indices of the two numbers such that they add up to target, which is passed in. Num is passed in. You may assume that each input would have exactly one solution. You may not use the same element twice. You can return the answer in any order. So if we wanted to try and combo every possible pair within nums, we could go for I in nums for every index that does not equal I. So 7, 11, 15. So I check, it's 2 plus 7 is 9. It's equal to target. We return a new integer with these two indices. Or here, I would start at 3, and I go 2, and then 4, and then I say, oh, it's not here, so I go to I is equal to 1. I'd start here, this isn't true, it skips over this one, it goes here, it's like, oh, we can return it. So how do we write that? We'll say that for int I is equal to 0, I is less than nums dot length, I plus plus, for every element in nums, man, I'm really sick. For int j equals 0, j is less than nums dot length j plus plus. We'll just say if I is equal to j, continue. We just skip if I is equal to j. We can't reuse elements. We'll say if nums I plus nums j is equal to target, return new int ij, the two indices, and then because Java freaks out if you don't have a return condition, we'll just say return new int 0. And if we run this, it gets accepted. Actually, I'm not sure if this one will get accepted. This one does get accepted. It's at the very bottom. You could technically optimize this by like making so j is equal to like I plus 1, so we're only searching the right half of I, but this is still considered O of n squared because we're checking every valid pair. So as for each element you add, the time complexity is scaling like in a quadratic equation. It's very interesting. So how do we solve this optimally though? We have to consider what we're doing in the problem. In the problem, we're going from left to right and saying, is there an element within nums when added to the current element is equal to target? And when your problem asks you for a quick lookup of something you've seen before, hopefully your first thought is hash map, my best friend. So we'll say hash map integer. Oh, I did not explain it. Did I explain it? I don't know. I'll have you yell at me later. Hash map integer map is equal to new hash map. I don't know if you remember what the hash map does, but we can basically say map, well, map keeps key value pairs. I can check in O of one, O, O of one time if key is in map and return value assigned to key. So what we're going to use here is say, hey, is there a value in nums, which we'll use as our key in nums, and then we'll just keep it in our map. I mean, fuck. We'll go for each I in nums, we'll say in our map, if there exists a number that we can add to it that equals the target. So we'll say each individual element will be the key, and the value will be the index it was found at. So we can actually implement that for int I is equal to 0, I is less than nums dot length plus. So for every element in nums, we're going to go through, and then we'll say int diff is equal to target minus nums I. We want to find, like, I guess the complement. So whatever added to nums I should equal the target. And if map dot contains key, diff if we've recently come across, so like for example, here I would go blah blah, I would be at 7, and then I'd say hash map, does my thing contain target 9 minus 7, 2? Have I recently come across a 2 in nums? And it is in my hash map, so I'll say, hey. So we'll say, return new int, uh, what is it, map.get diff, and then I. This will return a new int array with this is the first element, this is the second. Else we'll just map.put the current element comes I with the index, and then again it's gonna freak out. So, and the beauty of this solution is it's O of n time complexity. We're only running through the array once, which is pretty cool. Yay! It's the top one. There's probably, oh, what the fuck? What the fuck? Uh, okay, I have no idea why that one's super fast, but yeah, that's okay. I have no idea how those solutions work, but they're okay. Whatever. What else do I say? So let's just go over this again because I'm scared I didn't explain it well enough. This is a hash map. It's like kind of a magic box. Think about it like a dictionary. I can easily look up stuff in my dictionary and then the kind of definition or value assigned to it. So I'm going to go through each value in nums, check if we've previously saw this value that we need to complete target. If it is, then that, and then something, I don't know. Just yell at me later if I